The Compose Wear OS bootcamp, and in this bootcamp I will be building a very simple application that displays a scrollable list of composable items. As you can see here, this is the final result of the application. So we will try to build this, analyze it in the code, okay, and step by step we'll be building this simple application in Compose Wear OS. Okay, it's a very simple sample application for using Compose in Wear operating system. So what we will be doing, we will be also first talking about the introduction. We'll be talking about what's Wear OS. Then we'll be just learning how to set up, checking out the dependencies, the difference between the dependency the existing dependency in the mobile application, and what is the difference between the dependency that we will be using in Compose Wear OS. Okay, so then we will be also checking out some other sample composables for Wear OS, and we will be using scaling lazy column. What's the use of scaling lazy column, and then finally the scaffold and the final preparation of the application. So this will be the final application. Okay, so let's jump and let's try to understand what is Wear OS. Wear OS by Google is an operating system designed for wearable devices like smartwatches. So it provides users with a convenient and interactive way to access information, manage notification, track fitness, and use app right from their wrist. Okay, so there are four kind of surfaces in Wear OS. That is complications. There are small glanceable snippet of information displayed directly on the watch face, so ideal for frequently accessible data like steps, weather, or battery life. And then you have a notifications, that is a notification surface, that is a surface that helps to inform users about important events or updates. Okay, so they can be interactive, allowing users to take quick actions without opening the applications. So then we have a tiles surfaces, which provides a quick way to access app informations or launch specific functionalities. Users can swipe through tiles to get the snapshot of the relevant data. And then finally you have the app surface, that is a full app experience. So this will help you to give the full app experience, okay, offering detailed informations and interactions, so user can launch the app to access the complete functionality. Okay, so the key to successful Wear OS is application is to prioritize the content effectively across these surfaces. So you have to prioritize the content, that is the content with the highest priority should be displayed, like you have when you display the critical information or time sensitive updates in the complications, updates in the complications and notifications. So you have the high priority, just display them on the complication. Then you have a medium priority, use tiles to provide the medium priority contents, okay, like a summary of important data, or like offering the shortcut to frequently used features. Okay, then you have a content with the lowest priority. Then you have to use the app itself should contain the detailed information about the complex interaction and less frequently accessed features. Okay, so now let's first go to the setup. The first setup you have to make is like you have to create the emulator, okay, for testing your Wear OS application. So for it's pretty simple, just need to go to your device manager, check the create virtual device. Okay, then you have to just select the Wear OS, select the necessary what will be your device definition, like your square, rounded, rectangular, or large rounded. Okay, so you just choose the one of your preference. Then you just need to go next, and thus need to select the image, system image, that is I'm gonna select the upside down cake. And then you just need to click next and finish it. Okay, you just need to give the necessary simple configurations. I'm just use the configuration by default and just click finish. Okay, that's it guys. So I have already an emulator, so that's this one. Okay, and I have a Wear OS large rounded. Okay, so this is the first setup that you have to make. Then the second setup that so in Wear OS development with Jetpack Compose, most of the changes you need to make when adapting your app for Wear OS involves the top architecture layer of your project. Okay, so you have a Wear OS specific libraries for higher level, and then you have a lower level dependency that remains the same for the fundamental building block of Jetpack Compose, such as like UI runtime compiler and animation are shared between mobile and Wear OS development. So so this is the specific differentiation that you have to just keep the note on. So you need to understand that generally you don't need to change the dependency when targeting the Wear OS. Like the dependencies, like as I told you before, like the fundamental building block of Jetpack Compose, like UI runtime compilers and animations are shared between mobile and Wear OS. So that's remains the same. The only thing that changes is the higher level OS specific libraries, like navigation, like so so like for example the navigation styling, like material design styling, foundation, UI elements and navigations. So for this you need to use the Wear OS specific libraries. Okay, so these libraries are designed to provide the optimal experience on wearable device, taking into account like factors like the screen size is pretty small compared to the mobile, right? And then you have the shape and interactive patterns are completely different in the Wear OS. Okay, so that's it for lower level dependencies, like shared dependencies. You use the UI runtime compiler animation, as I told you, and for the Wear OS specific you use the material, compose foundation, compose navigation specified for the Wear OS. Okay, so you can check the dependency in my toml file. So here are my dependencies that I'm using. So okay, so if you check out the okay, you see I'm using Wear Wear OS dependencies, like compose foundation, compose material, compose navigation, as I showed. The rest remains the same. Okay, you also have the compose tooling. So just let me just here put it here. Let me just okay, here as specific libraries. The rest remains the same, guys. Okay, so that's it, guys. And what else? You can also go to my build.gradle file, and here are the implementation, as you can see here. So we have the Wear compose foundations, and Wear compose navigations. Okay, or compose material. So these are the things that we are using it here. Okay, so maybe we can also yeah, let me just leave it like this. Okay, so this is the first part of the setup and the understanding of the dependencies, right? So now let's move on to the implementation. So in case of Wear OS, we recommend to use the default Wear app. So let's me goes to the theme that is let me go to the main activity. So in main activity I've created a simple Wear app. So just go to my simple Wear app screen, and in this I'm using Wear apps theme. So why we use this default material Wear app theme, because we use it because the default material Wear shapes which are optimized for rounded devices, as you can see here. So we don't need to implement the shape. Okay, so shape are not implemented, it's just using the default material Wear shapes. Okay, so this will help to optimize for the rounded devices. Okay, so this is the first important concept that you have to understand. So after that, then let's move on further to the implementation. Let's go and check out the simple implementation. Like I'm using the composables. Okay, like some simple Wear app composables. Like first one is the button. So we have a Wear button. It's pretty simple. Like I'm just gonna use, as you can see, the import. I'm using the Wear compose material button. Okay, so it's pretty much, the implementation is pretty much similar with that of the mobile. As you can see that we have modifiers here, we have the on click this lambda, and then we have the icon for the button, right? So you can just check out the preview here. So yeah, this is a preview of the button. Okay, then we have a Wear text. This Wear text creates a text composable. So if you check out, this is like a Wear text. example that preview. Then we have the where card. As you can see here, this is the where card. It's pretty simple, like we are using the app card here. App card is actually dependency like of Wear OS. So as you can see here, it's a opinionated Wear material card that offers a specific 5-slot layout to show information about the application. Example, notification app cards designed to show interactive elements for multiple application. So it's especially designed for the Wear OS. So as you can see here, you have a modifier app image, then you have the app name, time, like title on click. So it's pretty much defined for the Wear OS. Okay, so this is a Wear card. Then we have the Wear chip. This is a simple Wear chip example. The implementation is almost similar. So this chip is pretty much it's pretty much defined for specifically for the Wear OS. Okay, so you can see the implementation is almost similar with that of the mobile, but toggle chip is like this is the toggle chip. You can see here, do something. So it just creates the a chip which is toggleable. Like you can just click on the chip to toggle toggle the selection. Okay, if you go and check out the toggle chip, it's a specialized type of chip that includes a slot of bi-state toggle control, such as radio button toggle or a checkbox. Okay, so that's it guys. And then I'm using for my accessibility, I'm using a semantics, that the content description, that if it's checked, then you have to just your talkback should pronounce on, otherwise it's off, right? So here is a simple talkback accessibility implementation here for the switch and for the toggle control, as you can see here. And then okay, so after that let me go out to my main activity, sample Wear app. So this is all the simple composables implementation. Okay, so now let's go and check out so we are also using, okay guys, there is also another interesting thing that we are using. We are also using one important library which is called Horologist. Horologist is a group of libraries that aims to support the Wear OS developers with the features that are commonly required by developers but not yet available. So if you go and check out my dependencies, guys, I'm using this Horologist library because these are the libraries which are pretty much like a group of libraries that aims to support the Wear OS development with features that are commonly required by developers but not yet available. Okay, so this is the reason what I'm using Horologist. And then sample Wear app. Okay, so we'll be implementing this library, and then we will be just using this Horologist. First thing is we're gonna use this implement the Horologist scaling lazy column. Okay, so why do you need to use the scaling lazy column? That extends the lazy column. We don't use the lazy column directly, we use the scaling lazy column that extends the lazy column to support both scaling and transparency. Okay, at the bottom and top and bottom of the screen to make the content more readable to the users. Like as you can see, the screen is pretty small. So right, whenever you scroll, the content should be like adapting with the screen size, right? So this is the reason why we are using scaling lazy column, because we need to support both scaling and transparency at the top and the bottom, as you can see here. So to make sure the content are more readable to the users, it adds padding for elements in the list that makes sure no elements are clipped on, like no elements are clipped on the top or the bottom, okay, on different screen size. So this is the reason why we are using scaling lazy column. So this is the most important thing that you have to understand. You have to use the scaling lazy column, not lazy column, okay, for for your for declaring your items, scrollable items. Okay, so then also we need to use the scaffold that provides we use this app scaffold that provides a layout structure to help you arrange screens in common patterns just like mobile, but instead of mobile specific elements it supports the where for where specific layouts on the top level components, like you have the we are using the app scaffold, screen scaffold. Yeah, like as you can see here, we have a time text, we have a scroll state or position indicator. Or position indicator. Then you have the content. Okay, so this is the screen scaffold. Okay, so this is the thing that we have to understand. And then app scaffold adds a time layout by default. Okay, so this app scaffold will add time layout by default, so this can be overridden by the screen scaffold, as you can see here. So it ensures the time text animates correctly when navigating between the screen. So scaffold is used in conjunction with the app scaffold and adds a position indicator to the list by default. Okay, so this is what it is, and as you can see here, we have the time text already also been present here. And so after that, so yeah, these are the modifiers used by the our Wear OS composables, and this is the list state that you will be using the remember responsive column state. So this is the state that you need to pass for your scaling lazy column for your like remembering your scroll the column state. And that's it, guys. This is all about the implementation. And yeah, we have our amazing cool Wear OS application, sample application, and hope you guys like it, and catch you up later in the next bootcamp for Wear OS composables. Thank you, guys.